We've done our area basics. We're going to look at the area of composite shapes. Obviously, these are two very, very simple examples. This area that's being cut out of this shape might be a triangle, so you'd need to know the area of a triangle formula. You could even have circular shapes that you would have to apply your area of a circle to. But I'm giving you the simple examples to just show you a couple of the methods or ways of solving this type of problem. Now, method one is what I call the additive method, where you're breaking up a composite shape. And composite just means it's made or composed of different shapes. So when you see that term composite material, which you'll see used for like Kevlar and stuff like that, it just means it's layered in different materials to give it added strength. So you'll see that word used a lot, composite. So in this case, composite shape is a shape that's made up of a number of different shapes, and the way to simplify this problem, like all problems, is to break it down into smaller steps and more easily understood things, and you'll be able to solve the problem. So for this one, for the additive method, what I do is I first of all divide this shape up into easily recorded ways of working out the area. So I need to break it into two rectangles, and you can see I could draw a line across here, or I could draw a line across here. And either way, I would know my length. So first thing I like to do always is, if there's an unknown side, just to make my life easy, I try and work out what the distance of that side is. And I know there's 10 here, so it's 10 from here down to here. So to make up the extra 5, to make it 15, I know that this length is now 5. Knowing that, I can break the composite shape up into two rectangles, this way or this way. I'm just going to do it, which way am I going to do it? I'm going to break it up this way. So I'm going to draw a line across here, and I am going to call this A1, which is area 1, and I'm going to call this A2. Now you might think that this is going overboard, but if you had a very, very complex shape, you should always set your work out methodically so you can find your answer and not make any silly mistakes. So the area of area 1, it's a rectangle, and it has this side which is 10, we know that, and this side that's 5. And we know that area is length times breadth, so we'll write that down. A equals L times B, which we learned in the last video. So we would say A1 is equal to 5 times 10, which is 50 centimeters squared. Don't forget the centimeters squared. And then we look at A2. A2 is 5 by 10 also. So knowing that it's 5 by 10, we would say A2. And you can see this is obviously not drawn to scale, because if it was, they would look like they're the same size. So be careful of that too. Quite often in these types of questions, they won't draw the diagram to scale, so you can't just get your ruler out and measure it. They want you to do it using geometry. So A2 is also equal to 5 by 10. So coincidentally, that's also 50 centimeters squared. And then if you want to know the total area, we write total area. I'll just move that up so you can see it. Total area is equal to A1 plus A2, adding those two areas together, which of course is equal to 50 plus 50. We know that that's going to be 100 centimeters squared. And that's how you use the additive method to work out the area of a composite shape. Now we're going to do what I call the subtraction method. Subtraction because we're going to subtract an area rather than add it. So this is very often a good method to use if you see a large shape that you know you'll be able to work out the area for, and it has part that's cut out, okay? Like a little cookie cutter, or someone's taken a bite out of it. So this subtraction method works really well with that. So first of all, you've got this giant rectangle. Actually not even a rectangle, it's a square because it has equal sides. And the square is 20 by 20. So we use our multiplication algorithm, because I haven't got my calculator here. 0, 0, 0, 2, 2 knots is 0, 2 twos is 4, is 400. So we have a large area, we're going to call that A1, which is equal to 400 units squared, because they haven't specified the units, so it's units squared. And then I need to work out this second area, which is A2, which is the cookie cutter part, and we're going to say it's equal to 5 times 4, which is 20. So A2 equals 20 units squared. That's that little bit that's cut out there. And then we use the subtraction method. So what we do is we say it's A1 minus A2. That's the total area. Total A equals A1 minus A2. So that's equal to 400 minus 20, which is equal to 380 units squared. So area equals 380 units squared using the subtraction method. So that's the two methods that you can use for a composite shape. One's addition, one's subtraction. You could, of course, play around with working out a composite shape method and using the additive method. I mean, for this method here, for this method I could make this one giant rectangle and subtract that part there, this chunk here. For this one, if I wanted to use the additive method, I could have divided it up into 3 areas. This one is 8 by 20, this one is 15 by 4, and this one's 8 by 20. So I could do an A1 plus A2 plus A3, but obviously using that subtraction method was a lot faster. Okay, so use the method you think is going to be the fastest one, but you can always skin a cat several different ways in mathematics. Anyway, that's me with the composite shapes methods. If you have any questions about this, approach me at